In this video, we're going to talk about the Intermediate Value Theorem. I have it mislabeled in my notes, so please make that change. And so here's what the mean value theorem says. You let f be a function which is continuous on the closed interval from a to b, including the endpoints again. Then for any number d between f of a and f of b, here's f of a, here's f of b on the y-axis, d would be any number in between those two, including f of a or f of b. Then there is at least one number c on the closed interval from a to b so that f of c equals d. So what this is saying is that if you pick any value of d on the y-axis between f of a and f of b, there's going to be some number here in the interval from a to b, some number c, where f of c equals a. So I've indicated a number d between f of a and f of b, and what the mean value theorem says that if the function f is continuous on that closed interval from a to b, there's going to be at least one value of c where f of d equals a. And in the next diagram, you'll see what the theorem is getting at. In this case, there are actually three values of c where f of c is equal to d. Any place where this horizontal line, y equals d, crosses the graph of f of x on the interval between a and b, the x-coordinate of any of those points is one of these c's that is guaranteed by the intermediate value theorem. Now, the intermediate value theorem does not doesn't tell you how to find those values of c, it just tells you that they exist. Alright, so let's look at an example, an application of the intermediate value theorem. Explain why the function f has a 0 in the given interval. What do we mean by a 0? A 0 is a number c such that f of c equals 0. So in other words, it's a number, it's an x-coordinate where the graph of the function crosses, or at least intersects, the x-axis. Alright, so we've got f of x equals x cubed plus 3x minus 2 on the interval from 0 to 1. This is a polynomial, and polynomials are continuous everywhere. So that's good. That's meeting that condition required by the intermediate value theorem. Well, now let's do the following. Let's evaluate the function at 0 and at 1. F of 0 is negative 2. F of 1, pardon me, is 1 plus 3 minus 2. If I kept track of all the numbers, that would be 2. Let's see, 1 and 3 is 4, minus 2 is 2. Alright, so what you notice then is that at one end of this interval, the function is negative, and at the other end of the interval, the function is positive. Since the function f is continuous on that interval from 0 to 1, that means it has to cross the x-axis. And where it crosses the x-axis is our 0. And finally, just one more thing. If the function were not continuous, would you still be guaranteed to be able to find values of c? Let me give you a fairly simple example. Let's take a look at the interval, say, from 1 to 2. And let's take a function that looks like this. Let's say it's constant on, say, this interval and constant on that interval. So let's say that this is, I don't know, let's make that 3 and that 6. Now, if according to intermediate value theorem, if the function f of x were constant, we should be able to find a c such that f of c equals d for any d we choose between 3 and 6. Well, what if we choose a d somewhere in the middle? Is there a c where f of c equals d? Nope. F of x is either 6 or 3. It's never anything else. So, in this case, there are values of d for which there is no c. So, what that indicates is that, if the function is not continuous, the intermediate value theorem doesn't hold.